Hello, and welcome to your last and final review for your study guide. We're going to go through the rest of the problems here up to 49. Really quickly, I wanted to make sure from our last video, I know it got cut off a bit, but you could pause and see if you were confused. And here I'm solving for a solution to the equation substitution to make them equal to each other. So I took this right here, which is what y is, and I replaced it into this y. Because that y is negative, that's why I had to add the negative here to the outside and then distribute that inside the parentheses. Right, so on question 40, we are continuing our systems of linear equations. Here they want you to write a system of linear equations to solve this problem. You're invited friends over to your house to watch a movie. You let each person decide if they wanted to snack on popcorn, which costs $2.50 per person. It's $1.75 per person. You spent $17.75 to buy for 8 people total. And we want to write an equation that you could use to determine how many people chose popcorn P and candy C. So we have to write the two equations, so we have to kind of make sense of this. So if popcorn is P, we know that $2.50 per person was popcorn and that $1.75 per person was candy. We're going to connect those two things. So we have two different things to take a look at. We need to know like the total cost if I were to buy all the popcorn and candy for these 8 people. But then I also am told that I am buying per person, and there's a total of 8 people, so I'm going to use an equation to equal that as well. So one of our equations is going to equal $17.75, and the other one's going to equal 8. We just have to figure out which one's which. If I'm adding, so P is really the number of popcorn, like people who are eating popcorn, and C is the candy. So if I add P and C together, I'm going to get the 8 total people. So I want an equation that when I add P and C together, I get 8. So that one is not going to work. This one does here. Okay, so far D seems to be more likely. The other thing is if I take the $2.50 per popcorn and I times it by the number of popcorns, okay, candy, that should get me the total amount that I spent on candy, $17.75. So this equation here for D should be the correct one, because if I buy this and this, I should be cents. Given the information that we are given, this should be the correct equation. All right, question 41 is another systems of linear equations, but in this case, you have to write the two equations. So here we have 2 different families that bought general admission tickets for the Reno Aces baseball game. One family paid $71 for 6 adults and 2 children, and the other family paid $56.50 for 3 adults and 4 children. We want to know how much more does an adult ticket cost than a child's ticket. We have to start by identifying what's going to be adults and children. You can use X and Y, that's totally okay. I used A and C so that I knew which one was adult and children. Over here, we just added, so I have 6 adults, so 6 times A, plus 2 children. 2 times C is the $71, that's family 1. And then this right here, this equation is representing family 2. Having this set up, it does give me a really good chance to use elimination. So what I'm going to do next is actually multiply one of these equations to get one of my variables to be eliminated so that I can solve. So because it wants how much more does an adult ticket cost than a child's ticket, that means I'm going to need both, so it doesn't really matter. So I'm going to go ahead and multiply. I'm going to choose, I think, this first one. Sorry for the glitching. And I am going to multiply this by a -2 to get the C to become opposite. So I'm going to go ahead and pause and do that for you. All right, after I have distributed my -2, I then added my 2 equations and eliminated C, and I found that an adult ticket would cost $9.50. So what I'm going to do now is I'm going to substitute this value into one of my equations for A and solve for C. All right, so as you can see, I expanded my area here, and on this side, I just substituted A into one of the equations. When I solved, I found that C, or the child's ticket, should be $7, okay? So now I have to go ahead and figure out, well, how much more is the adult ticket than the child's ticket? I would just subtract. You could probably do this in your head, but it's just going to be the $9.50. Take away the $7, and you can see That says 0. That's going to be about $2.50. So the difference between the adult ticket and the child's ticket is $2.50. And then I'm going to erase all this and show you how to bubble in your answer. All right, so as you can see here, I have bubbled in my chart. So I put our 2 in the first column with numbers. I don't need to worry about positive or negative if it's not really important that my answer shows that. Like if it specifically asks for a positive or negative, you can use that. You could put a positive here, it would be fine. I filled in the dot for my decimal point. That's its own space. Then the 5 here and the 0 here. All right, number 42, we're actually graphing one of our inequalities on our coordinate plane. So you can see here, because this is just a less than, we know we're going to have a dotted line. So we can already tell that C is not going to be an answer here. Okay. I already put a dot on our graphs where our y-intercept is, because 4 is our y-intercept, positive 4. You can see now that A cannot be the graph that we want. Because it does not cross the y-intercept at positive 4. And then our slope is a 3, a positive 3. So remember, I can go up 3 and to the right, but that means I can also go down 3 and to the left. So this has a positive slope of 3. 1, 2, 3, 1. This one also has a positive slope. So B and D right now are the same graph, except it's shaded differently. So when it says y is less than, that means that I want to go below the line. So B for number 42 is our answer. 43. Here we have another inequality, but this time we have to write the equation. So we had Sandy had at most $100 to spend on summer clothes. If shorts cost $12.50 a pair and tank tops cost $6.25 each, which graph represents the possible combinations of shorts and tank tops that Tandy can buy? So I went ahead and said, okay, shorts is X and tank tops are Y. I kind of did that because that's what our graphs say as well. Then over here, I wrote my inequality. So I had the shorts, the price of the shorts, times the X, the number of shorts, plus the price per tank top times the number of tank tops, has to be less than or equal to 100 because that's the most they can spend. I then rearranged my equation to get y by itself, so it's slope-intercept form, so it's easier for me to read on my graph. You could have also just made x 0 and found the y-intercept, made y 0, found the x-intercept. That is also an option for choosing to solve this. But when I did it my way, I got y is less than or equal to negative 2x plus 16. So I have to find a graph that matches. So my y-intercept is 16. So again, I know that C and A are possible answers, but B is not and D is not. Okay, and I now have to look, these are graphed the same, A and B, but they're shaded differently. So because y is less than or equal to, we are going to look at graph C for 43. Because that means any point that's inside this graph, okay, would represent the number of tank tops and shorts that Tandy can buy for $100 or less. All right, 44. We have a system of inequalities here, and we need to figure out which of these systems models this graph. So first we kind of took a look at one of the graphs that's going on there, which this ends up being one of the first ones. You can see that they're all kind of the same formula. It's just slightly different. Some have positive slopes, some have negative slopes, some are less than, some are greater than. So I'm going to first start with that equation because it's already in a format I know how to read from a graph to eliminate some of those answer choices I know are not right. So I start with my y-intercept, which is -1, which is what they all have, okay? And as you can tell, this line is going down, so that means it is a negative slope, okay? It is going down by 1/3, so it is all the same slope. So that means that because it's a negative slope, A cannot be my answer because that's a positive slope, and D, right? I'm looking right here. I want this positive right there. That's what I'm looking for. Sorry for the glitches. But those are the two things I'm looking for. So B or C are my answers. Because I'm shading above the line, okay, I also want something that's going to say y is greater. So far, C looks as though it's going to be our answer. So we're going to go ahead and look at C. You can also double check here. This one is saying I could rearrange this formula from C into slope-intercept form and make it negative 4y is less than negative 2x plus 8. Divide by negative 4, which will flip my sign. And I'm going to get y is greater than positive 1/2 x minus 2. So this will be the new equation that for this other line. And so you can double check it. Its y-intercept is at negative 2. That's correct. Its slope is up 1/2. That is also correct. So let me do it in a different color so you can see. So y-intercept up 1/2, that's correct. And it is being shaded above the line. So yes, C is my correct answer. On to number 45. Here we are looking at which of these points is a possible solution for this system of inequalities. They give us a graph, and it is easier to graph these so we can figure out which point is going to fit in that double shaded area. So I am going to go ahead and pause the video and graph this in red, and I will graph the other one in blue, and then we'll come back and see which one's the right answer. All right, I graphed my two lines here, so you can see the red one is graphed above and the blue one is a dotted line graphed below. I had to rearrange the second equation to make it easier, and because I divided by a negative, I had to flip that sign. Then I went ahead and we graphed these dots, okay? So I graphed the positive 1, negative 6 is here in green, which is not in my double shaded area. Positive 6, positive 1 looks like it's right on the line, but because this is a dotted line, it does not include anything that falls on that line, so it cannot be B. C is a positive 3, negative 3, positive 2. I graphed in the wrong spot, but still, positive 2 is way up there. That is not in our double shaded area, so the only one that's left would be positive 3, 1, 2, 3, negative 2, and this yellow dot right here is our answer, so our answer is D. All right, 46 is very similar to the problems we've done before. We had to create two inequalities based on the word problem, and we had to figure out which one's graphed correctly. I went ahead and wrote out my inequalities. He has to have us most 9 trees, peach and apple, and then this would be the cost is at most 600. I then made sure that these two inequalities were in a graphable format so that I could check. If you notice, all of these are the same graph, and I'm just looking for shading. A is our answer because it's the only one where both lines are shaded below. 7, they've kind of done all the hard work for us. They graphed it, the gallons of cherry and vanilla, and the highlighted purple is really the important question, which is it viable for the manufacturer to produce 10.5 gallons of cherry and 55 gallons of vanilla for the constraints that are up here in the problem? I went ahead and put a point. It's hard to see, but it's that glittery blue dot right there, which is about where 10.5 and 55 would be. So our answer would be yes, it is viable to produce 10.5 gallons of ice cream and 55 gallons of vanilla because it is possible to make partial gallons, and the point, which is x and y, lies inside the solution. Right, for these last two, I'm going to do the same thing. I'm actually going to solve the equation using the absolute value sign still in there. On this first one, once I solve down to where the absolute value is equal to a number, because the answer is negative, it has no solution. Because remember, the answer to an absolute value problem can never be negative because absolute value is distance and it's always positive. On number 49, though, when I solve, I get a positive 2. So that's where I'm going to split my problem into two parts, taking away the absolute value sign, one where the answer is positive, one where the answer is negative. I'm going to solve and get x is negative 2 and negative 6, which is B.